Hello, so Mr. Hunter here again. That's Cameron to you and me. And I'm going to try and do SP hybridization slightly differently so I can show you actually some videos of the model which may make things better for you. If you remember, hybridization is the mixing of atomic orbitals to form hybrid atomic orbitals. For SP hybridization, it's a little bit more special. I mean, it's not sp2, right? So that's kind of cool. So what happens here is that this time, two of the p orbitals are left unhybridized. And two of them hybridize. So those two form an energy between the energies of the s and the p. Now these two are the sp hybrid orbs. sp hybrid atomic orbitals. And these are remaining p orbitals, possibly px or py, for example. Remember, this was our 2s2 set and the 2p set with 2 electrons in it. Now, if this is carbon, this means that each carbon atom would have two sp hybrid orbitals. Now again, they've got that little node and they look a little bit like that, the mixture of the sphere and the dumbbell. So there's only two of them, so they separate each other like so. And that's going to give you this 180-degree separation. Which is characteristic of sp hybridization. However, so if there's another carbon, it comes along here, woo, and it also has sp hybridization. We'll talk in class about sometimes when they will and won't have particular types of hybridization. Just try and understand this just now. Maybe a hydrogen can come along here with its s orbital, and the electrons can share here, and another hydrogen can share here. That is giving you a sigma bond here, and a sigma bond here, and a sigma bond here. Now, what about those p orbitals? Well, those p orbitals, each carbon has one set above the existing sigma axis. That could be, for example, the py. Now the py will bend over above and below that sigma axis and form half a pi above and half a pi below, just like 18 did. But, dun dun dun, sp hybridization, there's another set of p orbitals, and these guys will be at 90 degrees to the existing p orbitals. They'll form pi overlap coming out of the page of that sigma bond and going back. So that's another half pi here and another half pi here. So you end up with sigma, hydrogen, sigma, hydrogen. And then you have this arrangement where you've got half a pi above and half a pi below, and half a pi coming out and half a pi going back. That's quite hard to draw, so I'm going to show you a model of that in a moment. And that equates to what we think is normally shown like that. Pi, pi, sigma. Oops, you can't see that down there. Okay. Now, The reason why I'm using this device is so I can show you a model of that. So here is, firstly, the old-fashioned thing that we come to love and know about this. This is ethine, and this is a model that would show ethine. It's a pretty inaccurate model. This is a sigma bond between carbon and hydrogen, but there's 3 bonds in the middle, if you can see. Yeah, you can see it better like that. One of these would be a sigma bond, and one of them represents a pi bond and another pi bond, and that's what we call the triple bond. But we know that that's not really a good representation of it. So put that model away and have a look at this one. Now this one's a bit cooler. Turn it around. Okay. Now, we've got pink and purple here. So you can clearly see that purple one. And you can clearly see the grey in the middle. There's the grey in the middle. So the grey here represents sigma bond between carbon and hydrogen here. Sigma bond between carbon and carbon here. And a sigma bond between carbon and carbon here. These sigma bonds are formed by overlap of sp hybridization. sp. Overlap of sp hybrid orbitals to give you this sigma molecular orbital. Finally, but it's the most important part really, above and below this sigma bond we have the pink p orbitals, and those pink p orbitals, we could call them the py if you like. It doesn't really matter. So there's a lobe above and there's a lobe below, and they'll stretch over to the other carbon's py if you like, and form half a pi above and half a pi below. But we also have half a pi coming out, because we've got a set of p orbitals that are coming out of the board and a set of p orbitals that are going back. So we have half a pi here and half a pi here. So you end up with this beautiful hot dog sandwich, as it like. Here's the hot dog in the middle. It's a sigma bond all the way down. And then you've got half a pi all the way round at right angles. Half a pi above, half a pi below, and then half a pi coming out and half a pi going back. And that is what we usually simplistically call a triple bond. Okay? And that's all for this little video on sp hybridization. Bye!